Hey guys, welcome to lesson 6.3, Trigonometry Applications. So right triangle trig is actually pretty applicable, like you can use it for pretty tangible things in your life. The chances of you doing so probably not super high, but you can. So I have a couple of examples here where you can apply right triangle trig to something in the world. So my first example, Kelly's visiting New York and she wanted to see how tall the Statue of Liberty is. So she got a little boat and she went about 100 feet away from the statue to look up at the very top at about a 71.85 degree angle. There are devices you can use to figure out the angle, like the approximate angle at which you're looking up at something. So this is her angle, and using that information we're going to figure out how tall it is. So it always helps to make a picture in these situations. Here I've provided you a picture of the Statue of Liberty for convenience, but you can't always have that. Sometimes you will have to make your own pictures. So here is the height of the Statue of Liberty. Kelly really, is about 100 feet away on her boat. So we're gonna say that, here's the water, here's Kelly's boat, and we'll put a little 100 feet down there. It's kind of ugly. Okay, and let's finish our triangle. This is going to be the third side. So the one that we're looking for is the height of the statue. So we're going to go ahead and put an X here because we don't know that information. But we do know one more piece of information, and that is the angle between like the ground or the water and where we're looking towards the top of the statue. So right over here is going to be our 71.85 degree angle. And then at this point, you can really just like ignore what's going on outside and think about this as just the triangle problem that it is. So the first thing we want to do is label our sides with our opposite, adjacent, or hypotenuse. So when you look at this side with an X, it is the farthest from the angle, and if we drew an arrow out, it would land on that side. So that means it's going to be the opposite side. So we'll label it with an O. The 100 is right next to the angle, so let's label this one with an A for adjacent. Okay, and we also can remember that SOHCAHTOA is spelled like this. Always have this near and dear to your heart at all times. Okay, now we can tell from our picture that we're working with O and A, and TOA, or tangent, is the one that deals with O and A. So we will proceed accordingly. We'll use the tangent ratio, so tan of our angle goes in there. In our case, it's the 71.85. And continuing on, the trig ratio fraction is always going to be over 1. And then on the other side, we have our actual O over A. So in our case, that's going to be X over 100, because our O is X and our A is 100. So at this point, we are ready to solve this using cross multiplication. So this is our first diagonal, and this is our next diagonal. So if we start with this diagonal right here, 1 times X is equal to just X. And then the other diagonal is 100 times the tangent of 71.85. Now it doesn't matter which diagonal you start with. Either way, it'll be the same thing. Okay, at this time you should notice that the X is already by itself, so we don't have to do any extra work to get it alone. So we're ready to go ahead and pop out our calculator and type in 100 times tangent of 75 just as we see it. Okay, oops, not 75, 71.85. And you should get an answer of 305.05. So the Statue of Liberty is about 305 feet tall. Okay. And we are done. All right, so let's try another one. Okay, Sarah needs to buy a ladder to get onto the roof of her house. She knows that the roof starts 30 feet high and would like to have her ladder make a 50-degree angle with the house. How tall of a ladder should she buy? So just based on the information we have here, we know that we want to start creating our picture, start making our triangle. We know that the bottom of the roof is 30 feet off the ground, so that's this height right here. We can go ahead and label it with a 30. All right. I guess that's not the best color. I don't know what color would go well here. Well, that'll have to do. Okay, and then we know that the ladder has to make a 50-degree angle with the house. So let's go ahead and get our ladder in here. The ladder is going to lean up over here, so we can say it'll look something like this. And then let's just finish our triangle. And there we have our right triangle. Now, it said that it makes a 50-degree angle with the house. So this time, our angle's not going to be down at the bottom here, because the ladder, which is right here, right, there's our ladder, it's making 50-degree angle with the house. So right here is the angle. Okay, and we want to know how long the ladder is, so we'll put an X on the ladder. So really, you know, ignoring all the external things, this is just a regular problem where here's X, here's 30, and we have an angle of 50 in here. Okay, so it's nothing fancy once you are able to make the picture. So now we can go ahead and label our sides with the adjacent, opposite, and hypotenuse. So the 30, because it's the side right next to the angle that we're using, we can go ahead and call that the adjacent. Oh, I don't like that. All right, and then this one, X, is the longest side, so we're going to call that the hypotenuse. Okay, and based on our good friend Sokotoa here, she'll write again. We can see that we're working with just A and H, so we want to focus on K, which is our cosine ratio. So we can start setting it up. We can say cosine of 50, because it's the angle that goes in there. Cosine of 50 degrees over 1 is equal to adjacent over hypotenuse. So for us, it's going to be 30 over X. And now we're ready to start solving through cross multiplying. All right, so my one diagonal here, 1 times 30, that just equals 30, and then the other diagonal is X times cosine of 50. So unlike the last problem, our X here is not already alone. We have to do a little bit of extra work. So to get X by itself, we notice that it's being multiplied by cosine of 50 right now. So to move it away, we need to do the opposite, which would mean we have to divide by the cosine of 50. If we divide both sides by cosine of 50, here it'll cancel out, which is the whole reason we're doing it. And here we get what we need to put in our calculator. So we'll type just that, 30 divided by the cosine of 50. And we get an answer of about 46.67. So, you know, we'd be all right if we had a good 50-foot ladder. We'd be able to make it. Okay, and that is all. It's really important for you guys to note that I won't always give you pictures to work with. Sometimes you have to use your imagination and be able to come up with these images on your own, right? Like if I didn't even give you that house, it's possible that you might have just started creating a picture, been like, okay, well, here's my house, here's my roof, here's my ladder, and here's the ground, and this is just as good of a picture as any, right? It would be the same thing. We got 30, we got X, and our 50-degree angle. So again, it sometimes takes a little bit of imagination, not too much, but a little bit, to be able to create a visual for yourself to refer to and go off of. It's really important. It's going to be real hard for you to do these problems without the picture. But that's all. Give the practice problems a try.